Hello class, today's tutorial is going to go over the two sample t-tests and the different methods that you can use StatCrunch to calculate use the t-test. Okay, and so two sample t-tests is when you have two samples that you're going to compare against one another to determine if the means of either sample are statistically different from one another. Okay, so here I am at question 3 of homework week 4, homework 1, and I am going to kind of give a guess here what this is going to be. Good, okay, I kind of knew that it had to be one of these three here, and I didn't really see any language that said greater than or less than, so I just went with not equals to. So I don't have any data here, so I'm going to open up StatCrunch, and I'm going to do this through the summary of the data that they give me within the question. Okay, so I don't need this to be so big. Let's see if we can share. There we go. Oh boy. Okay. Alright, so I'm going to do this through the summary of the data which they have in the question. I'm going to go to t-stats, and instead of one sample like what we did last time, we're going to go to two sample, and we're going to go with summary. Now what's important here, before you even begin, is to make sure you understand which group is sample 1 and which group is sample 2. Here we're basically just going to go with whoever was the first group presented in the problem. So the mean of this first group is 0.78. Standard deviation of this group is 1.58. And the sample size is 310. Second group, the mean is 0.56. Standard deviation is 1.21. And the total sample size is 376. Now the reason that you have to make sure that you are doing your samples in the right order is because if you have them flipped, you're actually going to get the negative of the t-statistic that you're going to calculate, and that will count you wrong, even though the overall value, the absolute value, would be correct. So you would perhaps get a minus when you should have a positive, or a positive when you should get a minus. I'll kind of reframe this again once we have the output. Moving on though, you can also see that one thing that's a little confusing between how the homework is kind of framing the hypothesis versus how StatCrunch is framing the hypothesis is that here, the null hypothesis is basically U1 equals U2, and basically the mean of group 1 equals the mean of group 2. Here what they've done instead is they said the group 1 minus group 2 equals 0. Okay, but that's basically the same thing. Saying that these two things are equivalent to one another is the same thing. If you subtracted one from the other, you would get answer of 0, okay, an output of 0. However, if they don't equal one another, then you would not get an output of 0. So although these look different, they are in fact the same. So don't let that be confusing when you're looking at these things and wondering if you're using the right test. Now there's just different ways of doing the same thing, unfortunately. Alright, now I'm going to click compute. It's going to give me my output. My t-stat is 2.01. Now if I had switched this around and I had gone, if I go back really quickly and I had this info here and this info here, I had switched them around, then instead I would have had a negative 2.01. My p-value would have been the same. This difference would have been negative, but that would have flipped the sign for the most part, and it would have given me the wrong answer if I don't enter in things in the correct order. So I'm going to put in my t-statistic here of 2.0, 2 decimal places, 2.01, check answer, good job. P-value 0.044, actually we'll round that up to 5, oops, 5. Check answer, fantastic. Okay, I don't need to do that. That's for you guys to be able to do. That doesn't have anything to do with technology. So moving on to the next one. This is the same thing. So again, also it's important to make sure you know what your statistical level is. And the last one, I think it was 0.1 as well. Our p-value is below. Something to keep in mind as you go from question to question. Okay, here's another one. We're going to delete this. And again, it's giving me just the summary, right? So it's giving me X bar means the mean of the treatment in the sham group, and S means the standard deviation of the treatment in the sham group, and N means the total number of participants in each group. So I'll do this again. T-stats, 2 sample with summary. I'm going to go with treatment, 0.48, 23, 27, 0.41, 1.19, 27. Here I might have to make sure that I know which direction my statistics are, what direction my hypothesis is. If it's less than or greater than, it's a one-tailed test. If it's not equal to, answer effective treatment background, the results shown on the table, blah, blah, blah. Assume that the 2 samples are independent. Greater mean reduction. Okay. Then treated with magnets. Okay. So this is greater or equal to. We don't really do that. You can even look at that here. There is no greater than or equal to. You can't have both one or the other. You can't have both. You have to have one or the other. Either greater than or not equal to. Check. Good job. Greater than. This is set up the right way then. This also has to be changed. Okay, so I know that this is my treatment group, U1. This is my sham group, U2. Looking to see if they're different from one another. T-test, ooh, not very different from one another, not at all. 0.25, oops, 0.25. Check answer, good job. P-value, 0.402. Okay, so you see that? So that was important to be able to first make sure I had the right sign here, just to kind of show you really quickly if I had done not equal to, so you already remember what our output was before. Our p-value was 0.4. And if I now make this 2 equal to, you see that the t-stat doesn't change, but the p-value now doubles. Okay, and that's what happens because basically depending upon what your hypothesis is, whether it's one-tailed or two-tailed, that's going to change how the area underneath the curve of our normal distribution, of our t distribution, is going to change dependent upon if we're looking for significance in one direction or the other. And so what this is showing here really is that it's really going in the opposite direction. So even though this is a small sample difference here, it seems to indicate, I don't know if greater is better. Oh yeah, greater is better or reduced is better. Well, basically it's none, but essentially it almost seems to show that there's no difference. And if we were going to take this at face value for what it is, it seems like it was only really a small difference. So this number would be greater than this. No, this greater would be greater than this number. So it looks like even that the sham group was doing just a little bit better, 0.07 better on whatever scale they're using here. So it actually seems to be going in the opposite direction of what our hypothesis would be telling us here when we're expecting a greater reduction in the pain. Okay, just make sure that you understand how all those things kind of work out. Can be a little tricky. Okay, yep, doing good there. All right, what do we have here? Here, basically the same thing as before. You have your n, you have your x bar, your means, and your standard deviation. The important thing to do is to test the claim that females and males have the same mean BMI. When it means the same, it means our alternative hypothesis is going to be not equal to. And that's going to set you up for essentially what your statistics are going to be. Make sure that when you read the claim, you understand that whatever the claim is, that is going to directly determine what your hypothesis is going to be. Okay. All right, let's see. Aha. Okay, this one is actually giving me data this time, so I'm going to go ahead and open that in StatCrunch. Looks like it opened it up into a different StatCrunch. Just going to bring it over here. And you see that I have actually different size groups, which is okay. There's nothing special you have to do about that. You don't have to have equal size groups with each one. You just have to make sure that any test of normality that these that these two groups are actually normally distributed, which they may or may not be. I see some ones and some kind of weird stuff going on here, but we're just going to assume it is. They're not asking us to do anything otherwise. Okay, so consists of the longevity of archbishops, and 2 consists of the longevity of monarchs. Test the claim that longevity of archbishops is less than for monarchs. So basically, bishops do not live as long as monarchs. That is our claim. I'm going to check the answer. Excellent. Now we're going to do our test statistic. Now everything we've done before has been with the 2 sample with summary. Now we have data. We're going to go with data. We're going to select our variables. So remember, group 1 is our archbishops, so they're going to go into the sample 1. And group 2 is our monarchs. They're going to go into sample 2. Our claim is that they don't live as long as monarchs, so we're going to flip that from not equals to less than. And then everything else looks good. We're going to click compute. Ooh, does look like they do not live as long. This confirms our hypothesis, at least at first glance. Our test statistic is minus 2.39. Rounding that to 2. Check the answer. Good job. Okay, our p-value then going to 3 decimal places, 0.011. Check answer there. Good job. Okay, this, you go ahead and take a crack at it. I kind of already told you, it looks like that archbishops do not live as long as monarchs. Interesting. Okay, I believe that's everything that StatCrunch wise we need to cover for this homework. If you have any further questions, please feel free to reach out to me. Thanks for watching.